Yeah, I have the Wacom Cintiq Hybrid, which is it's a big Android tablet with Wacom technology in it, and so you have the pen and all that kind of stuff like that, and it's really nice. But I just couldn't bridge the gap between having a tablet, the drawing tablet on the desk, and then looking up at the screen. It just the hand-eye coordination thing there just wasn't there. I like to draw directly on the screen, and so
Yeah, I would always feel like I was drifting at an angle, or it was
yeah.
a very strange feeling.
Yeah, and I'd have to say we're going to talk more about this tomorrow night on Corona Geek After Dark, but I'd have to say that that's one of the things that the pencil brings, and the iPad. I'll just say the iPad Pro and the pencil because you can't use the pencil on anything else but the iPad Pro, and the iPad Pro, as good as it is, doesn't work as well with the old school stylus, right? So like palm rejection doesn't work as well, even though it's phenomenal, and your precision isn't all as well. And oh, by the way, there are apps that are not really optimized for iPad Pro yet. So like I tried Zendesk, not Zendesk, that's a whole different thing. ZenBrush on the iPad Pro, and it seemed to have some lag and some parallax, where the tip of the device is um, shifted from where you're actually drawing, and that was even standing in the Apple Store using an Apple Pencil on an iPad Pro using the ZenBrush. So I was like, well, maybe they should have loaded up something better like Procreate that would have, demos the tool better. Um, but as far as drawing a line, because so there's usually things like parallax that people experience on different devices. There's drawing a straight line, which sounds like a simple thing to do, but if you on other devices, if you draw slow, if you draw a straight line very slow, you get this wiggle line. You don't get that on the iPad Pro; it's a straight line. Uh, and then the other thing is that once you've laid down a line, like on a sketch, if you want to go back over and draw over that line, sort of pull out the lines that you like, um, typically it's hard to hit that line on other devices, past generation devices, because it's like you just can't quite get the accuracy that you want. And with the iPad Pro, I have no problem drawing a straight line that's not curvy or not wavy, and then hitting a line that I've previously drawn, drawing over something, whatever. It's very precise. It's pretty cool. So. Well, hey, we didn't come here to talk about iPad Pro. We will talk about that tomorrow night on Corona Geek After Dark. So join us at 8 p.m. Central, 6 p.m. Pacific, 9 p.m. Eastern. Today, we're here for Corona Geek. Welcome back, and we're going to talk about our desktop development series. We've been developing a game for the desktop. I think we're 6 or 7 episodes in now. If you haven't already, go to youtube.com/coronageek. You can check out all the previous episodes that were there. We've been pretty much in line. We've stayed. We haven't jumped in and done any sort of developer interviews or anything in the middle, apart from the thing that we did last time with Ed, sort of on the fly. Ed announced his new game, and we kind of rabbit trailed into a whole conversation there. But for the most part, we've stayed on topic, and we've done everything from how to set up your project, how to do inputs from different devices like mouse, keyboard, what have you. We've looked at the game, we've got third-party assets, just all the things that you would want to know in a desktop game, and can also apply to mobile development, which Corona SDK is great for cross-platform. And I don't know, even is that really considered? I mean, when we say cross-platform, we're really talking about iOS, Android, Windows, blah blah blah. So we're still when we're crossing desktop and mobile, we're still kind of cross-platform, right? I mean, you could call that a platform, right?
Sure,
Same
yeah, yeah.
in the same sense. So it's still all very cross-platform. Joining us today is Ed Marina from RoamingGamer.com,
Oh, yeah,
and
that's
also Stephen Johnson from ZibalbaStudios.com. All right. So Ed, does anybody? Well, first of all, do you guys have any announcements? No. Yeah. No. How's the game going, Ed? Did you officially launch? Is it
yeah, we
like
officially launched. It's completely out there and available. It's got about somewhere between 150 200 downloads so far.
okay?
So, which is good. That's it's not the million that I was hoping for, but maybe this week. It's gotten one retweet from one of our target group, which is we created two themes. We created several themes, but there's two themes that come for free with the game to start with, and one of them is the YouTubers theme, and that includes 8 different YouTube guys. All guys, sorry. We didn't put any of the ladies in there, but it seems like guys do more of the Let's Plays, and we put Let's Plays in there. Anyways, we got a retweet from Rock Lee Smile, who is one of our featured YouTuber theme individuals, and that was nice. And so we're just looking for it. I won't tell you how many millions of dollars we made this week because it wasn't in millions, but it's all good.
I would think that the hardest part about, I think that, first of all, I think the YouTuber integration, right, rolling them into the app, I think is genius. It seems like the hardest part of that, though, would be letting them know about it because they have, they get so many comments and there's so much for them to kind of sift through that you have to get their attention.
That is true. That is. Mike has done a lot of work on that, and it is in fact true that it was a lot of digging to get the contact information for these people and to get the contact, get the notices to them. And then we still don't know if they've gotten the notices, if they've spam foldered those, or what's going on there. So.
Have you guys considered doing a kind of a guerrilla marketer sprint campaign where you do some advertising directly to that YouTuber, right? I've seen campaigns in the past that do blitzes. Like one guy ran, and of course there's a cost associated with it. I'm not saying there's not, but depending on what platform you're on, you can manage that in different ways. But I've seen blitzes where, like Toby Turner, for example, somebody wanted to get in touch with him, and so they just basically ran an ad on YouTube, and they were kind of like, hey Toby, get in touch with us.
Hey Toby, get in touch with us. The ad.
Yeah.
I gotta write that down.
Yeah. And I'll send you a link, but I've seen other references to going on things like LinkedIn or places where you can say, like, I only want to target the friends of friends, and then you get all their friends talking about this thing. Man, when I go to LinkedIn, all I see is this ad for you. What is up with that, right? And that's enough people go talk to this person about it, and the person goes checks it out, and then you reach the goal of what you want to do was to reach the original person.
That's very funny. I like it.
Yeah, so some creative hacks out there. So anyway, cool. Well, cool. Yeah, keep us updated on it. Any Coronium issues or anything? Having a couple hundred people on the server?
No issues there. I mean, there's still a bug. It's not in Coronium though. I'm pretty sure there's a bug in OpenResty. So Coronium supports a feature where you can cache or uncache. So when you're doing development, you're modifying your scripts, you have everything running in uncached mode. And then once you are ready to release, I'm sorry, part of my brain is engaged in thinking about what we're going to talk about today. Once you get ready to release, you want to set caching mode. And what that does is the first time any script gets loaded, it stays in memory forever. And so that way you don't have to do disk accesses every time you want to launch a new script, which is launched, of course, every time somebody accesses your server. And so you're many-fold faster. But the problem is that we uncovered this kind of interesting bug where if you are getting multiple requests from the same client for the same record within a certain period of time, you will get a conflict on the network address. And what it is, I haven't quite worked it out yet, but something to do with the status of the connection. It's basically something that's getting kept in memory from the last time that function call executed, and it's illegal and crashes that response, and then you're doomed.
Huh.
I mean, it eventually times out, and then the server doesn't die or anything, and that user can continue to do other things, but that one request they made just basically hangs for a few seconds, and then they finally get a response. And so what we were seeing in our game was when we turned on caching, every once in a while when somebody would start a multiplayer game, it'd be like nothing. It would just hang for a minute. Like it wouldn't start the game. It wouldn't give you any indication that it had gone on to the next step, and we couldn't figure out what was going on. And then suddenly you'd get this response, and the response was, I couldn't do what you wanted me to do, basically. And that's not exactly what it said, but that's the essence of it. So I was like, what? It's pulling my hair out for a long time. And then I finally dug into it, and it's kind of like this OpenResty problem. So
There was an update this morning of OpenResty itself.
Yeah, I tried. I got really creative on this. I dug into it, and part of the thing is Chris is using a version of OpenResty that's pretty different from the ones that I've been able to find. So what I tried to do was I tried to take the latest version of OpenResty at the time and say, okay, I know the problems in these scripts. Let's compare. Wow, they're so different. It's like I need to do a total drop-in replacement. And then I tried doing that. That did not work well either because then there were conflicts. It's me not knowing the underside of how this whole thing was put together. So this sounds negative, but Coronium is awesome for the fact that you can go in there and like pull apart the guts and try to debug it on your own if you need to. But in this case, it's just me having a lack of understanding of these moving parts, and so it's just I'm going to have to keep working on it. But I mean, right now we've got it uncached and it still works just fine.
Okay, so it's really just performance. You're trying to just optimize.
We would like to optimize performance. What we'll have to do at this point is once it gets popular, so we'll just have to increase the size of our server because we're using like a minimal sized slice to handle the excess traffic that goes with the disk accesses. Now, the thing that's cool about this is and I know I'm just going on here, but this is useful information for folks. So let's say you get stuck in a situation where you're using Coronium and you've got to have an uncached setup. Say you run into the same problem I'm running into. You're probably going to be fine still. So what happens when you start to get a lot of accesses? Now, we don't know 100% why this is, but our guess is what happens is the server will do an access, it will load the file, and that file will get cached either in the buffer of the SSD or the drive or somewhere in memory. And so you don't get tagged with the same load hit you do for the first one. So you get a big load hit for the first one. Big, I'm just throwing out, whatever the size is, it's still very fast. But the next time that script gets loaded, if it gets loaded within the next like 5 seconds or so, boom, it's very quick. So even uncached, it's very quick. So it's kind of nice. So for us, actually, more traffic is better than less traffic.
Yeah, and I've heard other stories in different tools, right? Other web technologies that are kind of like, well, we couldn't, we didn't want to spend the time to optimize up front, so we just, like you say, we just kind of quote unquote, threw some money at it, and just went up with a larger container, and then later when they kind of reach that point where they're like, we know that we're making money on the thing, then they go back and they spend the time to optimize, because they're.
That's the cut we made. We said this thing is functional, it's not going to crash, it's working. Do we spend more time trying to fix this, or do we release it now and then look for a solution in the interim, or push that off? And we did that. We pushed it off.
Yeah, and I know how you feel though, because I think we're similar in the idea that we like to, be as efficient as possible right up front, and best practices, and optimize, as we go, and all that kind of stuff like that. But then there's just this other mentality that's kind of like, just get it out there, iterate on it, make sure that it's going to actually be a profitable venture, and then come back and retool and optimize. So
you can go down that. It's the same problem with adding more and more features and never getting done.
Right.
Exactly. You have to call it good and move on.
Yeah. My next step is just going to be a button on the screen, and then I'm going to iterate from there.
Yeah. That purchase button on the screen is a start. And that's good enough.
And some kind of analytics just to see if people tap it. If people tap it, then that tells me that I'm onto something.
Very good, Charles. Very good. Oh man, I'm trying to do something that I'm obviously not allowed to do with the debugger here, and this is frustrating me because I want to demo something for folks today and show
How are
them.
you,
Show them.
do you have the latest version of Corona, or are you talking about your debugger? You're talking the one about
It's
the one
just the
that's.
debugger I'm using.
Oh, okay. I
I
was
mean,
wondering
you're
if.
making a mistake. Well, I'm trying to do something kind of weird.
Oh,
I'll
you're still
explain it when
using
we get
Zero Brain,
into it.
right?
I've got part of it working. I'm trying to do this thing where I'm showing visually what's going on with the calculations, but in order to do that, I have to break each step up and pause it,
Hmm.
and then have the debugger stop on a breakpoint so that it renders the next frame so you can see the thing that's going on. I'll show you. It'll make more sense in a minute.
Well, okay. So let's just so everybody understands where we're going. Let's make sure we frame it for them. So I said in the show notes that we were going to talk about firing weapons, killing enemies, and rendering terrain, which it's probably going to be a lot more than what we can handle in one show. But what is it you want to cover today?
Definitely firing weapons. I would like to actually go back, and last week we talked a little bit about the enemy movement AI, and then I suggested out of the blue some improvements, and I made those improvements, and I just want to show people how easy it is to incrementally improve things and get a very nice result. I mean, it was really just a few more lines of code. I'll show you the two different AI functions compared to each other, and I think you'll be impressed by how easy it is to just elaborate a little bit and get a very significant improvement in behavior.
Okay, cool.
And then we'll go on to firing because that's the next thing, and then my mind is sort of like totally blank after that because I got caught up in trying to show debug output for this thing. Huh. I wonder if I shouldn't just remove the. I'm talking to myself now like a fool. Where is it?
These are the internal thoughts. These are
Oh, here's this.
these are the
Here's the
calling
problem
items.
right here. Foolish man. 2 seconds. Say
That's
something
good.
interesting.
Ah.
Problem.
So Stephen, you say lots of plugins.
Yes.
You like decentralizing the issue? Is that what you're talking about? Like
Oh
make.
well, we run across a problem and say, well, we would have to do this and this and this, but we'll have to distract ourselves doing that, sink lots of time into it.
Hmm.
But someone else has already written it.
Ah.
It
Yeah.
probably tested it and
Yeah,
it found it.
and that's definitely one of the things that Corona is, has tried to address over the years, right? Everything was kind of coupled together, and then it went and it decoupled a bunch of stuff, turned it into plugins, created simultaneously created a plugin system, and now we're seeing developers creating plugins, which is great because there are things that come along that are like not core, right? They're not the foundational pieces. They're great pieces, but they're not something that the engineers really should spend time on if someone else can kind of create it themselves and share it with the community. Love plugins. Plugins is great.
Yeah, and this was in response to throw money at the problem.
All right. Yeah.
Okay. I'm not going to be able to get this working the way I want it to in time for the discussion. It'll make sense mostly, so we'll plow through it, and I will show you my screen, and we'll go from there.
Okay.
All right.
I kind of like the trial by fire kind of stuff. It's a lot more interesting.
Well, I really wanted to show. It'll make more sense in a second. Make sure I've got the right screen here. Let's not do the tunnel of death.
I spray painted the poodle. I wanted to show it to you. Come on.
Yeah, okay, let's not share my screen. Spray painted the poodle.
There you go. That's a soundbite for you.
All right, so yay. Where are we? Where am I? I don't know. You tell me. Let's go ahead and look at the AI first, and I will stop doing this. And we will turn off the debugger. Sorry. I will run it. Now we get to see the game on the screen. Oh yeah. All right, so last week we talked about a couple of interesting things. First of all, you can see that I've got one enemy on the screen, and he's moving super slow. And the reason he's moving so slowly is because I have set. Come on now, come across. I've set some new variables in common, And one of them is called enemy min speed, and the other one is called enemy max speed. Now, normally that's going to be a range between 75 and 150. In other words, the enemy will move towards us at a speed of either 75 pixels up to 150 pixels per second. Now, for my testing, I made it really slow because I wanted to play around with shooting at the enemy and not have to worry about it killing me because I'm distracted as I talk. But last week, you asked me, Charles, about animations and scaling and stuff like that, and I talked about the timescale attribute. Mm-hmm. So the cool thing here is let me find the code, and I'll demo it for you. So last week I showed you guys that sprites have this variable called, let me zoom in a little bit, called timescale. And what you can do is you can create a base animation that runs at, let's say it's got 10 frames and it takes 1 second to iterate, so each frame takes 100 milliseconds. But then you've got a situation where you need to make that faster for one sprite instance and slower for another sprite instance. So what do? You've got two options. Your option one is to create more named animation sequences and use different sequences for different animations. So it's going to be the same frames, but then you could change the time to 2,000 or 500 milliseconds or something like that. But that's not very efficient. I mean, that's good if you know those are the only three you're ever going to need, like slow, regular, and fast. Good, you're set. But if you need to be extremely dynamic, what you can do is you can find a base speed that works for you, and then you can adjust it. And so what I've done here is, let's go ahead and put this back up to 75-100. What I've done here is I've created a variable called base speed. So my assumption is that the animation when it plays at normal rate should be considered normal for moving at 60 pixels per second, which is what I've set here. And then my actual movement speeds are going to be between 75 pixels per second and 150. So what I do is I say, let's go ahead and get the enemy speed. Let's find the code here. So we randomly select a value between the minimum speed and the maximum speed. And let's just assume that that's 75. In fact, I'll force it to be 75. Just for this demonstration. And further on in the code, well, not very much further, I look at that speed and then I divide it by the base speed, and that gives me the time scale. So, for example, if my speed were 120 and my base speed is 60, then my time scale multiplier is going to be 2. So in other words, play the animation at twice the normal rate, whatever it was set to in the animation sequence. So now I'm choosing 75, so let me go ahead and just run one of these for you. And stop it, and reload it. Reload it. And here's our guy walking, and he's chasing me around. And that looks, you know, pretty good. Let's shoot him and get another guy. Oh, nuggets. I introduced the bug. Yay. Okay, well that's cool too. I love it. Okay, so as you can see, it looks good. The enemy is doing his thing, and it's all good. All right. Oh, there. Looks like I finally killed him. Oh, you know what I think is going on here? I've also added a feature for this show where I can cause these guys to regenerate. They generate on screen so you can see them. So anyways, let's go ahead and ramp up the velocity. Let's just stop this for a second. Let's ramp up the guy's movement speed to the maximum. Let's force it to always be the max. So to do that, I just simply set the min and the max to the same value. So when that random statement executes, which is right here, it's basically saying a random value between 150 and 150. So I'm not giving it any real choices. So now it's going to be 60 over 150 is my time scale, which is like, I don't know, what is that? Almost 3. So let's go ahead and see it. And this back and forth screen thing is kind of weird. Woo. Okay, now he looks like a freak. Freak, get away from me.
So now he's really chasing you.
Yeah, he's really chasing me. But you can see, woo, you can see his movement rate has sped up significantly. And I don't know why he's spawning or dying. So I've obviously introduced an error with this bug, or with this code, that I will have to fix. Oh, I think I know what it is. It's the timer. Okay, so what's going on here for people who are wondering why he keeps respawning when I shoot him is I'll show you the code that does this in a minute. It does his movement. But what it is basically is there's a timer. And, oh, that's nice. Now he's moonwalking. It's the moonwalking bug. Excellent. So let me get this back over here, and I'll show you the code.
Nice.
It's too funny. Let me make this a little bigger so everybody can see. So what's going on there is, let's just see. Let's see the. Oh, come now. So as you can see, this guy is constantly following me now. Like last week, our AI would walk to a point and then go, oh, he's not there anymore. And then it would turn and chase me again. Now what you see is basically every 10th of a second, it checks and sees, has the player moved? Has the player moved? Oh, he's moved. I need to go and aim at the new place where the player is. So over time, it's constantly updating the animation that it's playing and the direction that it's walking in to try to catch me. So as you can see, with just one player, I'm having, well, it's moving at 150 pixels a second. Let's slow this guy down a little bit.
So is that a combo of what we did last week, where you said,
Yeah,
hey,
yeah, it is, and I'll show you the code. And I just wanted to show you what it was doing first.
Okay.
This is probably too big now. So last week's code is right here. And just to reiterate what we did last week, basically what we do is we have this function called move to player, and I set it up one time, and then I call it below. Now I'm calling move to player 2, but just pretend that this still says move to player. So it calls it, and what that does is first it checks, is the game running? Okay, yes, it's still running. I can go on to the next line. Is this object still valid? Which is a function in the common code. And let's find it. It runs this little bit of code, and my valid check is basically, does it have a function called remove self? What happens is, on a side note, when you remove an object, the very next frame after it has been removed from Corona, there will probably still be a little Lua object left over, but the Corona stuff has been stripped off. And one of the things that's been stripped off is the remove self function. So if you've got a reference to an object and it doesn't have a remove self function, you know that it's been removed. It's been deleted. And it's on its way out, probably going to get garbage collected soon. So I check to see if it's valid. And the reason I do that is because I'm going to do some things here where I'm going to call some methods on. I'm going to set a transition or try to modify it in some way. And if it's not a valid object, I could crash my game at this point, or at least cause a bug, or do something bad, and so I want to avoid that. And so I just check to see if the game is running, and I check to see if the enemy is a valid object, and then I start to do my work. And the work from last week, I'll run it again so you can see the difference, is we calculated a vector between the enemy and the player, so basically an arrow, if you want to think of it that way, pointing from the enemy to the player. And then I got the angle out of that. I stored that aside so that I could use it to select the proper animation, because as you'll recall from last week, we don't actually rotate the enemy. We choose a new animation based on the rotation that it's supposed to be facing in, or the direction it's supposed to be facing. Then we get the length of that vector. So how far away is the enemy from the player in pixels or in design space? And then we simply grab our speed variable, and then we divide the length by the speed, multiply it by 1,000 to get it into milliseconds, and we use that for our transition time, which is right here. And then the only thing we do before we start to move the enemy is we set the appropriate walking animation with the angle that we are currently facing at. So, let's see. So this is last week, and basically what it did was it would walk to where the player was at the time that it started, and if the player wasn't there anymore, on complete would fire, and using the trick that I gave you last week, you just pass in self, and down here I set on complete to the function that I want it to call, and it would just simply call the move to player function every time the transition got done. So it moves, gets to the end, calls this function again, does all these calculations, moves again. And so it's a big zigzag pattern that it just keeps trying to track down the player. So let's go ahead and see that one, and then we'll go back to this code in a second. So there he's going to move to where I was standing, and then he's going to move to where I was standing. So, you know, he's still following me, and the closer he gets, the more it seems like he wants to really just move quickly. But if I reload it, and then I move immediately, it's apparent that he doesn't do anything until he gets where I was the last time. So he's moving way too fast to demo this properly. Let me put this back down to 75. This is what happens when you do live coding. It's the live coding show, folks. Let's try that one more time. You can really see it happening. Okay, so he's going to get to where I was standing, and he's going to turn left. Get to where I was standing and turn right. So it's very apparent now that he's moving so slowly that it's not like paying any attention to me. It's just wandering off, which might be good for a zombie, but we don't want that. We want our enemies to be a little more proactive. So how do we make a more proactive enemy? Well, we spend hours and hours and hours, or we can just spend a few minutes modifying the original code. So I created a new move to player function. I called it move to player 2. I used my imagination. And I go through the same steps. Is the game running? Is the enemy valid? Calculate the vector, get the angle, get the distance, and calculate the time it's going to take to move that far. And then here's the small difference. The small difference is I say, okay, is there more than 600 milliseconds left in the move? In other words, is the enemy kind of far away from the player still? Because at the speed they're moving, it's always going to be some amount of time. So when they're really close, it's going to be less, like 100 milliseconds. But if they're halfway across the screen, it's probably going to be 2 or 3 seconds. So 2 or 3 seconds is definitely more than 600 milliseconds. So assuming that the time is greater than 600 milliseconds, I just picked this number out of a bag. I kind of experimented a little bit. What I'll do is I will create a function. I will create a reference to this function here, move to player, and I'll store it in a variable called timer. This is another trick you can use. So I have a variable called timer on the enemy now, and it refers to the function that I'm actually executing. And then what you do is you say timer, perform with delay, wait 500 milliseconds, pass in the reference to the enemy, and what Corona says is, oh, you passed me a reference to an object. Does that object have a field named timer? It does. Okay, I'll execute the function that variable is pointing to. And for people, you can do a lot of cool things with this. As a side note, this is a great way to create a programmable state machine for people who want to take this out and do something cool. You can create a state machine where every state changes some timer function or some other function and reprograms where all this functionality is pointing over time. So anyways, back to the world of AI. So what we've done here is we've basically said, yeah, it's going to take a while to get there. So in half a second, do this again. Check again. Do I need to turn? Do I need to move someplace else? But meanwhile, it drops out of this piece of code. And the only other thing we did here was I added an additional tracking variable called my last angle. Now, what this is basically it gets this far in the code and it says, the last time I ran this function, was I pointing in the same direction? Did I need to walk in the same angle, 45 degrees, 180 degrees? Because if I did, I really don't have any more work to do. I'm already walking in the right direction I'm walking in the same direction I was last time. So I'll just keep walking. And so what it does is it aborts this function early. However, if your last angle is not the same as your current angle, then what we need to do is cancel the last move. So we use transition cancel, which cancels the last call to this line here. So on the first time through, this line does nothing. Then we do a transition. Then on the second time through, assuming our angle is now different, we will store that angle, cancel the last transition, which is this one here, and then we'll change our walking animation, and we'll do a new transition based on the time that we calculated and the direction we need to move in. Now, I want to show you what happens with and without this canceling line, and it may be subtle. But let's go ahead and use our new mover. So move to player 2, then we call it here, and let's reload. Now our dude's walking at us, and as we change direction, he quickly faces in a new direction to come after us. So this is all nice looking, but let's go ahead and take that bit of code out that I was just showing you. So let's take this safety code out here. So now what's going to happen is, now this was something I discovered when I added this AI. What's going to happen is every 500 milliseconds, it's going to come back in and execute this function, and it's going to restart the walking animation. So what will happen is the walking animation will get these little weird skips in it. And it's just real subtle. You're probably not going to see it. Let's try slowing them down a little bit. It might make. Oh, did I save? Maybe that's the problem.
So are you saying that the skipping happens because without you moving the player?
Yeah. So what happens is the animation takes, I think, 800 milliseconds to execute. It's got 8 frames in it. But this function gets called every 500 milliseconds, so it only plays frames 1, 2, 3, 4, 5, and then I reset it, and it goes back to 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you get this little point where he doesn't finish putting his left leg out, or whichever is the end part of the animation. And I'm waving at the screen like you can see me, but which I do all the time for people watching the show. I wave at the screen like you can see me. But the point is this animation only gets partway through before this function over here executes again and resets it. So it's kind of it's more subtle. It really shows up if I make the player move slower. So let me make him move really slow.
Yeah, and that makes sense. It's not a matter of the function running too fast. It's just a matter of skipping frames in the animation.
Yeah, no, the function's not running too fast, but because the function doesn't have this little safety code in here that just aborts early, every 500 milliseconds it just restarts the animation. So even if it's walking in the right direction, it starts a new transition and it starts a new animation. So when the enemy is moving very slowly, so I set it down to 25 pixels per second, the base rate's 60, so that's going to be about half. So the full animation is going to take somewhere around 2 seconds to play now. But because I reset it every half second, we're only going to do the first 2 frames over and over and over, if I've got this all right. And now it's working perfectly. Great.
That's okay. It would probably be hard to see on the Hangout anyway.
Yeah, so it'd be hard to see. So let's do one more thing, and then we'll go on to firing, because we got enough time to do that, and that is interesting. Let's go ahead and put, if you recall from last week, I put a variable in common called, let's put this back out here, called max enemies. So now we're going to use the smart enemies that realign themselves every 10 times a second. They check. I'm sorry, I had it, and every half second now they check to see if they're pointing in the right direction. But now it's going to be 10 guys, and let's see how we fare. Last week we were able to handle 10 guys no problem. Yeah, relatively easily. And let's go ahead and make sure that they move between 75 and 150, so random speeds. Let's go ahead and see how that feels. Yeah, that's going to be a problem.
And so at this point, they're doing what? It's just a bunch of them all going into
Yeah,
dynamics.
so this is 10 guys that are all doing their darndest to come after me. They're not waiting until they get to where I was at. Now they're, yes, we're doing the group them up as a big group of enemies thing. And then, that's the sound effect we're going to put in the game, and I did something wrong. This is what I get for adjusting the code. So let's take that out, and let's pause the game, or kill it. And let's take a look at the firing code. So, in Player Maker, which is the code to make our player dude, let's go ahead and zoom in a little bit here. We got a bunch of stuff. This is, I won't go through all of it, but it's a module just like always. Public, table, do the requires we need. I talked about the base walking angle on a previous show, but this is a table that basically lets us choose the angle at which we're going to be moving based on the animation that we're playing, so north, northeast, east, etc. Because we lock our player. Did I do this? Am I doing this right? Here. I set this all up, and then I'm not doing what I said I was going to do, so let's do it right. I set this up with code so that we could pause it, and I could show you the code on the side. So on the side here, we lock our player in. Let me reload him and walk him around. You can see he only moves at fixed angles. So basically every 45-degree angles he can walk in that direction. He doesn't walk omnidirectionally. And stop. So that's where this is coming in. Then we'll do some localizations to get some speed up. So we get math random, we put it in a variable here. So if I call that a lot, it's going to be a little bit faster. One I use a lot is pairs, so I use localized pairs. We have the destroy function, which is called when we restart the game or we want to load a new level. And this basically destroys the player. It stops listening for the enter frame, mouse, and key events, and then we clear it. And we also get rid of all our arrows that are being counted. Then there's the create function, which we talked about previously. We pass in the reticle, which is this little bugger right here. And we use this to determine the facing direction of our player. So we create the player, we add the body, we set up some variables such as the angle it's facing at, and we keep it in a different variable from rotation because we're not going to rotate it again. We're going to just keep track of the angle and play the correct animation. It's always rotated at 0, so never set to anything else. We set the base rate of movement, so if you wanted to experiment in this game, I could have put this in common, and I probably should have, but if you want to experiment with different move rates, you can change this here. We're only going to allow the character to move forward, so move Y is keeping track of whether or not the forward button is pressed, which is W or the up arrow key. I think I did both. Let me check. Yes. So as long as you are, basically what it does, oops, whoa, what's going on there? Basically what it does is moves in the direction, it's freaking out. All right, stop freaking out. So moves in the direction you are facing. So we keep track of that in this variable. We'll get to it in a minute. And for today's talk, we have a new variable called isFiring. So isFiring keeps track of whether or not we have done whatever it is we're supposed to do to tell the player to fire. Now, in this game, the way we tell the player to fire is we press the left mouse button. So the reticle, the reticle here tracks the position of the mouse. And when we click, what we want to do is we want to have the player play an animation and then produce an arrow and fling that arrow off in the direction that it's currently facing. So we'll get to that code in just a moment. When we're creating the player, we have the current facing angle, so we play the correct animation based on that angle. And our current animation is paused when we start, but later on that'll be walking. So we're paused facing at 0. That's paused, and for whatever reason it's facing down, but we'll just leave that alone for now. Okay, so movement was via the key input, and it was very simple. We looked at this previously, last week or the week before, but it's the W key or the up key, and then assuming that we are pressing that key down, we set the move Y to -1. Otherwise, we set move Y to 0. So a -1 value says move forward, which we'll use later in our enter frame. And our enter frame will do a number of things. It will face the reticle, and then it will check to see if move Y is less than 0, which means that we are supposed to be moving forward. And I won't go through all this code, but the essence of it is calculate the angle we're supposed to be facing, play the correct animation, and change the velocity of the player to be moving at the correct rate in that direction. But you saw me zip by today's code, and today's code is the mouse code. So, way down here on line 107, and just as a warning to people, this code for the player, I said it previously, it's very complicated compared to the rest of the game. It's probably the most complicated piece of code, and so it grows and grows and grows. So when you're first starting out, by all means, you should be looking at the other bits of code and then work your way up to looking at the player code. But just be aware that it's going to be a long piece of code and semi-complicated. One of the things that I have added to the player for this week is a function called mouse. Now, there is an event called mouse, which I listen for, and I use the listen function, which I wrote in Common. Let me show it to you, which is a piece of code that I stole out of SSK, but I so love it that I did not want to use the runtime equivalent. So let me show it to you instead. Just type, this would super be awesome. Okay, so there are 3 runtime functions that you can use to set up arbitrary listeners. Now, an arbitrary listener is a listener that is listening for an event that has a name that may or may not be one of the standard events. So a standard event is mouse, touch, collision, pre-collision. Those are all standard named events that Corona defines. However, the beautiful thing about Corona and Lua is that you can create, well, in Lua it's a little bit different, but the beautiful thing about Corona is you can create arbitrary events that your objects will listen for and then do something when they get those events. So on press or on key or on player died. I mean, you can just make up all these nice event names and then do something when that event occurs. So there are 3 functions that let us do this. There's the runtime add event listener, the runtime remove event listener, which people should be familiar with because they use them all the time, or should be using them pretty much all the time. But there's another one here called dispatch event. Now, a lot of people don't use this. I don't think a lot of people use it, and they should become aware of it. What runtime dispatch event does is it injects a named event into the Corona event cycle, event tree. And it's what's called a global event. A runtime event is a global event. It can be seen by all objects, all scripts, everywhere. And so you can create listeners that are global listeners, or you can create listeners that are attached to objects. So for example, let's say you had smart zombies and dumb zombies, and you wanted the smart zombies to chase the player, but you wanted the dumb zombies to just like wander around. So you could add a function on the smart zombies called dinner bell. Let's just call it dinner bell. And every time the player moved, you would cast an event called dinner bell. You would dispatch the event dinner bell, and then that code would run on each zombie that had the dinner bell listener and do something smart, like aim at the player and walk in the direction of the player. Whereas the dumb zombies, not having this event listener, very funny. Steve asks, do the dumb zombies try to eat the smart one's brains? Maybe, I don't know. Whereas the dumb zombies not having this listener would not do anything. So I use this all the time in my code. It's I could not get by coding without the ability to add listeners to my various display objects, etc. And the reason is I like to keep my code very disconnected. Let's say, for example, I want to have a HUD, heads-up display. It's like a score counter. I don't want the score counter to have to know about the player or have to know about all the different elements in the game. What I would prefer to do is have a player that can do something that gets it a score and simply dispatch a score increase event and have the HUD listening for that and say, oh, the score increased. I don't know who did it. I don't know about the player. I don't know about the enemies. I just know about me, and I'm listening for this one event. I'll increment the score by whatever this event tells me to. Now, I know I'm going on and on here, but I really want people to understand that this is very important. And we have used this, if you go back into the previous shows, we have used this for all of our previous score counters and things like that. And maybe it was subtle or I kind of glossed over it, but this basic concept gets used over and over again in this series. And so if you haven't learned how to do it, you can walk back into the previous games and look at the episodes where I talk about the score counters. That'll be a good starting point to understand this. So back to where I started. So I am what I like to term a lazy programmer. And as you can see, runtime, I always forget. When I'm typing, I always forget, is it runtime uppercase or lowercase? And then colon, add event listener. It's so long that being a very lazy person, I made myself a tiny little function called listen. Nice and short, all lowercase. I can remember how to spell it, and it's quick to type. Additionally, when you want to dispatch an event, the way you dispatch an event is something like this. You do runtime, event, and then you create a table, and then you create a field in that table, and then let's say we want to dispatch the dinner bell event. Then we'd say name equals dinner bell, and then we can pass along some parameters, like let's say we give it the position of the player. So we go x equals 100, assuming that the player is at x100, and whoops, and y, come on now, work with me, and y equals 200. And now, any functions or objects listening for dinner bell will get this event and be passed x equals 100 and y equals 200. But you can see that was super, super long to type. Now, that's why I have my shorthand notation, which is simply post, name of the event, I could type, and then my additional parameters table, x equals 100, y equals 200. Now, this doesn't seem much shorter, but most of my events are typically something like just an event name, and so let's make this one a little more normal for me. So normally, I would just pass a name for the event. So for the dinner bell event, I would have to type runtime, dispatch event, blah, 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 open parenthesis, close parenthesis, or bracket, close parenthesis. I mean, it's just long. I'm always forgetting the runtime upper lowercase thing. I don't know what it is, if I'm slightly, diminished capacity or what's going on there, but I just can't seem to remember. Anyways, post for me is much more straightforward. Another thing is I come from a different environment where post, listen, and ignore were the names that we use for our event dispatching environment to start with. So being familiar with that, SSK has listen, ignore, and post, and because I love them so much, I stole them out of SSK and put them in common. So, long story short, let's go ahead and go back to, where were we? Enemy? No, we were in player. Oh, that's the problem. We were over here. So now, I have an event for the mouse that I want to listen for. Mouse is a known event. However, my code works with known events and arbitrary events. So I simply say listen for the mouse event and let the player be the one who is listening. And to do that, I use the trick that I keep talking about, which is I create a field called mouse, same name as the event, on the player. And what I'm doing here is actually I'm defining a function that this field will reference this function, and it's got all this code attached to it. So now, whenever the mouse event occurs, it'll say, the player object was listening for that event. Does it have a field called mouse? It does. Okay. Execute mouse, pass in player as the first argument, and pass in the event details as the second argument. And then, when that event occurs, we check to see, as always, is the game running? Is the player valid? Hasn't been deleted yet, or nothing bad happened. It's not been destroyed. Then I do a little shorthand. There's a number of variables in here, and at this point, if you want to learn what the variables are, you can go back and look at our mouse project, which is in a subfolder. It's under top-down shooter app, I believe 1 or 2. We did a keyboard examination and a mouse examination, so that's in there. But I extract the primary button down. See, now I love Corona, but sometimes I think they got these really super long names, and this is one of these cases. I mean, don't take this isn't an insult or something. You can't really avoid this because there's primary mouse, middle mouse, secondary mouse button, which is basically left mouse button, middle mouse button, right mouse button. So I pull out primary. I could have called that left, but I'm already using a variable called left elsewhere. And what this is telling me is it's either going to be true or false. In other words, pressed or not pressed. True will be pressed. And then I say, am I firing? Okay, I'm not firing. Initially I start off, and is firing is set to false. Is the button pressed? Okay, the button is pressed. So I'm not firing. The button is down. I set a flag on myself, is firing. I set that to true. I change my animation to be the base animation. But then, actually, I keep track of what the last animation was that is playing, because when I fire, I'm going to go from my current animation to a firing animation, and then I'm going to flip back to whatever I was currently playing. So if I was paused, just standing there, I'd be playing the paused animation. If I was walking, I'd be playing the walking animation. So I store the animation, whatever I was at last, and then I change my animation to shooting. And the enter frame code down here, which was keeping track of our walking, was also playing whatever our current animation is. So that's handled for us. And then I call the fire arrow function. Now I'm going to go ahead and cut out all this code. Actually, I'm going to set this to true and see if we can make this work. Okay, so let's go look at the fire arrow function. And shrink it down a little bit, shrinky dink. Boy, this is quite a lot of code. Okay, so we call this function from player, and the first argument that gets passed in is a reference to the player, and then the second one is an argument that I put in for this show. And basically it's saying, if this is true, do some additional steps to show what's going on. And what those additional steps are...
Yeah.
Yeah.
Can I ask a question?
Sure.
So go back to the mouse code.
Sure.
Just kind of, I just want to make sure I'm. Like you said, this is a fairly complicated piece of code, so I'm having a hard time hanging on. So I just want to make sure we recap everything for everybody so they know where we're going.
Okay.
Okay. So I got that you're kind of doing the loop there, where you're saying the mouse event is on the player, and the player is passed into the mouse event, right? That little circular thing that you got going on there, and then what we're doing after the button has been pressed is we're setting the initial state to not firing, right? Because we want to start someplace, and then after that we're saying, okay, now we're firing, and then we want to play the shooting animation. And now we're going to go into making the arrows go in the right direction. Is that what we're doing?
Yeah, let me start over here. Okay. First of all, when I create the player, I create a variable called isFiring, and I set it to false. Now, the reason I do that is because I may have mentioned this before. The mouse event is very noisy. So you get a new mouse event every time you click a button, move a scroll wheel, or move the mouse 1 pixel.
Uh,
So if you think about it, you can move the mouse hundreds of pixels. So you're going to get a mouse event regularly. You're just going to get all these mouse events. Boom, you're going to get a barrage of mouse events coming in. And so assume that I have clicked the button and then I'm kind of like jiggling my mouse a little bit because my hand is unsteady or I'm having a good time at the game. I'm moving, I'm doing my thing. Then you're going to get a bunch of events where this is set to true. So what you need to do is you don't want to like constantly reset the firing algorithm. So what I do is I say, start off with a flag on the player saying I'm not firing, because that's the
Makes
state I
sense.
start in.
Yeah.
And then the first time I detect the button has been pressed and the firing flag is still set to false, I set it to true. So I click the button, I'm moving my mouse. Everything after that first click is going to be ignored. Why? Because the first click came in and it set this to true. And so it's going to come to this check the second time, the third time, the fourth time, and it's going to go, nope, it's not false, it's true. And so we ignore all this code and it just drops out and does nothing. Otherwise, it would set the animation again, it would set a new perform with delay, it would do the fire. Well, this code's a little bit excessive. It would do the firing, it would set the I just fired the arrow, everything would be all goofy. So,
And this is happening. I mean, we're talking like fractions of a second sort of stuff.
yeah, this is
right?
happening every frame.
Okay.
What happens is because it's a noisy event, you'll get a bunch of these stacked on top of each other. So every frame, it'll process like 10. If you're moving the mouse a lot, it could process 10 mouse events, one after the next.
Okay.
So, which of course would just blast you.
So really, we're compensating for the fact that the input device is we're using it in a way that isn't really what it's intended for, right? I mean, we're not really, you know what I'm saying? Like all these events are being passed in all the time from the mouse, and we only want to pay attention to a portion of that.
I want to grab a select few and ignore it most of the time.
Right.
Right? Because everything you pay for is, well, you pay for it. So do as little processing as you can. And one way to do that is just to ignore an input when you don't care about it. And so that's what I'm doing, basically.
Okay. And then, and so this is one of those desktop concepts, right, that we didn't have to deal with with mobile, but, well, not necessarily.
Yeah, we don't have to deal with it as much in mobile because this is not true, though, because you remember we had a discussion in a previous show where I talked about touch coalescing?
Right. Right.
So that's
similar.
I do mouse coalescing too, but it did not apply well to this situation because what I didn't want to do was miss certain inputs because I coalesced. Basically, coalescing is in a sense ignoring extra inputs, and so that's complicated because an input may have multiple state components to it. Was the button push? Was the button down? You can imagine a case where if I was doing mouse coalescing, where I would throw away all the extra mouse inputs and just grab the one that came on the frame, that I might miss the button presses because it always came after the move. Did a move, did a button press. And I only paid attention to the one where I didn't have the button pressed down. I threw it away. I'd never get any button fires. So I needed to catch every one and only pay attention to the ones that were exactly what I needed. So I'm not coalescing. I am simply saying, yep, I'm not firing, and you're pressing a button. Let's shoot that bugger.
Okay.
So speaking of shooting the bugger, I'm going to go ahead and, I said we wouldn't do this, and I'm doing it anyways. We're going to go through this briefly, because I went through all the trouble to do the drawing code, doggone it, and I wanted to at least show you part of what's going on here. So we're in here. I'm setting the do debug variable to true up here. So I pass in true. I say self : fire arrow. And when I use the colon notation, what that says is pass in the calling object as the first variable, and then everything else that you pass after that comes as the second, third, and fourth variables, and so on. So I set this to true. As always, I check to see if we're running because I deferred the call to that by 250 milliseconds. So in that quarter second, the game could have stopped running for some reason. So we're still running. You can ignore this code for right now, but basically what it is a limiter, so it doesn't let us fire any more arrows than our max arrow count is allowed to be. But this is for another show. The arrow shooting code will evolve over time. Right now we just care about how to get that arrow moving in the right direction. So we'll skip down. Skip the code that says the limit fire rate. Update the arrow time, and go to where it says create arrow, which is about line 226. Maybe a little bit different when I commit this code because I think there was a bug I need to fix. We call the arrow maker. Arrow maker is a piece of code that creates a sprite that is appropriate to the direction the arrow is supposed to be pointing in. So we pass in the group that we want it to be in, the starting position, which is the player's position, and the angle that my angle, which is the player's current angle, and 1, which is the scaling factor. So all of the makers, the sprite makers, have scaling factors that you can pass in, and they're currently all scaled to 1, but of course if you want the arrows to be a little bigger or a little smaller, you could change this to greater than 1 for bigger or less than 1 for small. Now 1 is the appropriate size. We add a physics body. We use a dynamic body because the arrow is going to be moving. I use a radius, so I don't make it the shape of the arrow. I just make this little circle. So if I were to turn on debugging, which I won't do, as the arrow is flying, you would see a little circle around the center of the arrow. But it's just approximate, it's good enough. And as I said on a previous episode, circles are better because they're the quickest calculation you can do for collisions. So the arrow is going to be moving quickly. You just want to do a quick calculation. Use a circle body. It'll work.
And the circle is in the middle of the arrow, you say?
Yeah, it'll be in the middle. It'll be at the position of the arrow. So it'll look like it's in the middle of the arrow because the graphic for the arrow may extend beyond the circle radius, which is fine because the arrow is going to get there quickly enough that even a glancing hit should be close enough for that circle in the middle to actually hit the enemy. And so you can adjust the size of this. You don't want it to be actually the full size of the arrow because then an arrow that goes by the side will still hit it because of the radius being so far out from. So the arrow is very narrow but long. So you don't want the radius to be half the length of the arrow because then it'll seem as if the arrow is behaving like this wide body with it is not. So an arrow that goes by.
And is the circle not on the arrowhead because you're also using a circle for the enemy, and that would look odd?
The circle is not on the arrowhead because the position in Corona is based on the center of the graphic. The default position, the anchor position, is 0.5, 0.5. So when you draw, for example, the player here, you can see that there's a red line, which is, in a moment, you'll see signifies the direction the arrow is going to go. Mm-hmm. The center of our player is where that starts, and that is the position. The position of our player is right here, and the graphic is rendered relative to that around the center. That is the center, it is the position. So it used to be in Corona that the anchor position was 0, 0, which was the upper left corner. Mm-hmm. So that has changed back when we did the transition to Graphics 2.0.
Yeah, the reason I ask is, it just seems like an arrow, right? In physical space, the arrowhead would hit the player first.
Yeah, you would think, oh, maybe I should move that over to the arrowhead. The problem is now you got to translate the position of the body. It's a lot of math. Mm-hmm. At the 0 angle, it's easy. You just move it up a little bit. But as soon as it's facing at an odd angle, it's a tremendous amount of math to do, and it doesn't buy you anything. Because the arrowhead, if you think about it, the arrow shaft is going to point, it's going to pass through the same position that the arrowhead does. It's going to be very little difference, deviation. In the time it takes for that arrowhead and the arrow body to move, there'll be very little difference between the point of impact of where the arrowhead looks like it's hitting and the middle of the shaft actually travels. Yeah. So if you have a small circle around the center, it's almost the same as having put it around the head. And for accuracy's sake in a game, it's fine. It's a trade-off. Do I want to do all that extra calculation to get that arrow body in the right position, or do I just have the arrow moving fast enough so that they're relatively the same when they hit?
Okay.
So I'm a lazy guy. I don't do too much when it comes to extra coding. All right, so what I'm trying to show here is these next steps. Oh, look at this, all lines up just perfectly. So we're doing the debug code, and this red line that you see here represents the vector that the direction the player is facing. The player is currently facing, it looks like, about a minus 45-degree angle. And I don't know why it says minus 72, but oh, that's it. Right, so this is the current angle of the player, but then we coordinate this down into steps of 45. So this is going to come down to being closer to minus 45, and so we'll default to minus 45, which is this angle right here. So the first step is we calculate an angle. We calculate a vector based on the player's angle, and we get this line. And then we will, this is very hard to read, so let's just go down here. So this line of code could essentially be considered to be this vector here that you're seeing. And as you can see, I fired, and my arrow is traveling along that line there. Now, why is it not on the line? This goes, it's kind of hard to see, but there's a shadow here, and then there's the arrow here. Really, the body for the arrow is right here on the line. The center of this graphic is right here. But because we're using an isometric graphic that has a shadow element, does this make sense? Are you seeing what I'm saying?
Yeah. So
Yeah.
if we had a box around the graphic, then it would be on the line.
Yeah, if we had a box around the graphic, you'd see that the center was right here, but the rendered part for the arrow is up here, and the rendered part for the shadow is down here.
Right.
So that it looks right when it's flying, but the physical body is here, which gives you this large margin of space where you can actually hit the enemy. So, what am I saying here? Okay, so we have this line, and it's just this long line, and then we scale it. Now, I couldn't give you a representation of that because a scaled vector here is going to be this little tiny, like 1 pixel length dot, because it's a math space thing. It's not a visual thing. I can't make it so you could see this arrow. But the point is that we start off with an angle. We calculate a line, which is a vector, based on that angle. And then we have already generated the proper graphic at this point. And then we simply scale that vector to be the length of our arrow speed. So if our arrow is moving at 150 pixels per second, it will take this long line and then scale it down to 1, and then scale it back up to 150 pixels long. Then we take those two components, the x and y components, and we put them into set linear velocity. So, this sounded so much better on paper when I was doing it, but it's still not clear. So.
Yeah, I think there's a couple of things involved here. One is the concept itself, and then the other part is the math. I think for me personally, I would do well to understand the concept, and then kind of come back to the math because it's.
Let me slow the players down to 1 player and make it slow so you can see me firing. Because what I did was I played lines showing you what's going on, so you can kind of see how this is firing and scaling and stuff. And hopefully, I got it right. Coming 5, and let's make that 1, 1, and 1. Max enemies 1. Guy moves it. Let's make him move at 10 pixels a second. Make it a little bit faster. Restart the game, and then I'll fire, and you'll kind of see what's going on. So where's our enemy? Oh, let's put him on screen. Offset 150. And generate on the screen. I don't know why he's not deleting. Generate another one.
It's like a laser archer.
Yeah. Oh, we're gonna have laser turrets later. Patch, remember?
Oh yeah.
The zombie game is only as good as the laser turrets. I got 5 enemies now, so this will be a little more interesting.
Okay, so what are we looking at here?
So what we're looking at here is the yellow line is the aim line, and then the red line was supposed to be the adjusted velocity line, but I'm not doing it right. So it was supposed to get shorter than the red one. So it's supposed to be yellow and then turn red, and the red one would be the length of the actual velocity vector. But I did something wrong. It's not working.
Okay.
So, but when I commit this code, this will be working. What you'll see is yellow for a moment, and then it'll turn red, and it'll be shorter. And that will demonstrate the principle, which is a velocity vector has a certain length. And so the x and y components we pull out of that vector, which determine where it faces and how long it is, are used to actually set the velocity of the arrow. So it was just supposed to demonstrate the math. It was supposed to give you an ability to look at what happens on each step of the math. And I totally failed because something is not right with my math.
Okay. Well, maybe we should come back to that one next week and
I could at the very least demo it working correctly so people can see.
yeah. And in the meantime,
the principle here is incredibly simple. The thing is I'm driving at is that people who want to make any kind of a shooter absolutely have to understand vector math. You have to. You can't get around vector math for aiming, creating velocity vectors, steering. All of these behaviors require vector math. But vectors are very simple. I give you a library. That's the Math2D library that you can get as a plugin. And you can take an angle, convert it into a vector, scale the vector to be the length you need it to be, and then apply it as the velocity or whatever it is, the force, whatever you're using it for in that circumstance.
okay, so let me make sure. I want to restate that just so people are clear of what you just said, and that is that you can do all this stuff manually, but you've created a plugin which is in the Corona plugin store that they can add to their project, and then it helps them do the math so that they don't have to be vector math wizards in order to use this.
As you say, let me turn my camera on instead of the screen here. As you say, better to understand the principle than necessarily the mechanics of it. I think, sort of paraphrasing you there.
Something like that.
And my library lets you understand the principle without knowing the cosine, sine, arctangents, and all that nonsense that is, this is one of those things where you can kind of know how to do it without knowing the background. So you didn't have to have that class yet in school. You can learn it for game development. And man, by the time you get to that in school, if you're a younger person and take in geometry and all that later, you're going to be ahead of your class at that point because you're going to be like, yeah, I already know how to do vector math.
And that's a good thing because sometimes you just need to get something done, right? And then once you're confident that it's going to serve your purposes, or you're at a point where you're ready to learn the details, right? Then you can kind of dig into it. But sometimes you need a little bit of the training wheels kind of thing, right? I mean, there's a reason.
I kind of think so, yeah.
Yeah.
I see a lot of times in the forums, people ask questions, and they're trying to do vector math. They're literally trying to solve these things, and they constantly do well, I did a cosine and thing, and they show you their code, and you're looking at it going, man, you could just do that in one line of code, and then later on when you know how to use the tool, then you can go learn what all that stuff is. But it's, first of all, it's trigonometry, but the math that goes behind doing vector math is kind of deep math if you haven't already had it. I mean, you have to understand all these principles about angles and the limitations of the sine, cosine, arctangent, and the concepts that go behind that, and you can't just walk in and go, okay, this is the one way it works, I'm going to do it. No. There's a lot of stuff you have to understand.
Yeah.
So better to use a tool to grasp the higher concept first, and then worry about the fundamentals when you get to that point in your schooling, or if you really need to dig into it for another reason.
And this is almost back to where we were at the beginning of the show, where we were talking about getting something out there, getting it working, and then optimizing it later, right? It's better to have something in place to see if it's even going to be a success before you spend all the time optimizing it and then release it.
Yeah. I mean, I was in their shoes, and I did exactly what they're doing. I went through it, and I kind of learned it longhand. But man, at that point, I was wishing that somebody else would just give me a function that would just do it. Because I wanted to get it done, I spent days trying to figure this stuff out. Oh, speaking of which, I'm going to give you a link for the show to my #1 document where people who are not going to listen to this advice and they're still going to go learn all this stuff. Like Appendix B, and I'll tell you what it is for the show, but it's a book that I have on my bookshelf that is now free in PDF, and it's got this appendix in it that goes through the trigonometry, the sine, cosine talk, and whole concept of the vector. And I still refer to it to this day when I forget something, some fundamental detail. So it's a great reference that I think people who want to dig in, they can use. It's very short and understandable.
Awesome. Okay. Well, okay. So in the meantime, you send that to me. I'll put a link in the show notes. I think what to take away from today's code review, like you said in the beginning there, that people need to, one, go back and watch some of the previous videos to learn how that mouse functionality is being built up, and then also take that along with what is presented today. You can download the full source code. That links will be in the show note, and then you can step through it and see how everything's functioning. And like we always encourage here, tweak it, break it, right? You can always reload it. You can always go back and unzip the file again and just internalize what's going on there. And if you have questions, let us know. Post your comments in the video comments below and let us know, and we will try to answer those on a future episode. All right. Okay. Well, next time we're going to do what? So that was firing. Do you want to do terrain or killing enemies next time, or do you have something new?
Well, killing enemies is a super simple step, so we'll do killing enemies, and then we'll go right into terrain. I mean, there's nothing to it, right? It's a collision handler, and you do something. The arrow hits the enemy, you do something. So what do? We'll go over that next time and talk about what the something is, and then we'll go right into terrain rendering.
Excellent. All right.
And then after we get done with terrain rendering, we can finally get into pickups and traps and stuff.
Oh, sweet.
We can start making this game actually strategic.
Right.
Right now it's just us shooting, and that's so fun.
Up to this point, though, I think there's been plenty of stuff to cover and lots of groundwork, and so you definitely can't skip these pieces, right? I mean, there's no point in having traps and all that other business if you can't move the player around, you can't shoot enemies, all that stuff. So, so join us tomorrow night. We're going to have Corona Geek After Dark. This is going to be number 17. I think we're going to talk about the iPad Pro. I've got the Apple Pencil. We're going to talk about Google Play's requirement for you to mark your games as ad-supported if they are ad-supported, and a whole bunch of other things. So join us tomorrow night, and until then, we'll see you next Monday. Have a great week, and happy coding.
Auf Wiedersehen. Tschüss.